Now we're going to analyze ethers and their IUPAC nomenclature. Ethers are characterized by having an oxygen atom separating two chains. This is the functional group. A single oxygen atom separating two different chains. So, what we have to analyze is that we have two bonding arms attached to a single oxygen. Let's draw a specific example, a very simple ether. So we have carbon on one side, carbon on the other side, which is the same as drawing this. And what we effectively have here, remember, we have to find the longest chain, and after the longest chain, we have to find the substituent. The funny thing about ethers is that we name them in IUPAC according to the nomenclature of alkanes. So let's think about this. I'm going to find the longest chain to which the functional group is attached. So here it's essentially 1. So this yellow part I'm going to name methane. But what is attached to this methane? How do we call this remainder molecule, which is an oxygen with a methyl group attached? Here is where I'm going to introduce the topic of alkoxy groups. An alkoxy group is like an alkyl group with an oxygen atom that is interrupting the chain. Therefore, methyl will become methoxy. Ethyl will become ethoxy. Propyl and its different shapes will become propoxy. What we're essentially doing is we're separating the IL, the YL ending, and we're substituting for oxy. Now that we know the name of this orange structure is attached to our main methane chain, and it's called methoxy. So here we have methoxy, which is a substituent that's being added to the main chain, which is methane. And that's how we do a IUPAC name for this chain. Let's do another quick example so that this is clear. And from the way I'm going to draw it, it should probably result as something that's clear. 1, 2, 3, 4, 5. And right here at number 2, I'm going to attach methyl group. Okay? So, once again, I find my longest chain. My longest chain is obviously 5 carbons long. And then I have an attachment at number 2, which I'm going to assign the lowest number. And what is attached? A methyl being interrupted by an oxygen atom. So my longest chain is pentane. And at number 2, I have methoxy. Let's try another example. My longest chain, it's pretty obvious in this example as well, is 7 carbons long. I want to assign the lowest numbers. So I begin, let's see, 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter on what side of the chain I begin. I write a 7 to remember that it's 7. So then it's heptane. And what is attached to this heptane? At number 4, I have the isopropyl shape attached to an oxygen atom. Thus, this is going to be isopropyl, but since it has the oxygen, it becomes propoxy. So this is at number 4, isopropoxy. Heptane. So remember here, it's the same thing. It's an ether because it's 2 different carbon chains linking to a single oxygen atom that's in the middle separating. Let's look at one final example. And we're going to draw this, this, and then this. My longest chain is how many carbons long? I'm going to count them. It's going to be 4. So let's see. 1, 2, 3, 4. Attach the oxygen. And on the oxygen we have 2 carbons. So then this would be, to give it the lowest number, we start numbering here. 1, 2, 3, 4. Butane. And then at number 1 we have ethyl with an oxygen interrupting in the middle. So this becomes 1 ethoxybutane.